For this lesson, let's talk about linear equations. In example 1, I want to graph the functions f of x and g of x and see where they meet. Now these are both lines, so we have f of x is equal to x minus 2. Here the slope is 1, the y-intercept is negative 2. And for g of x equals negative 1/2 x plus 4, the slope is negative 1/2, and the y-intercept is positive 4. So if we graph these, I'll start with f of x. I'll put a point at negative 2, and the slope is 1. That means it goes over 1, up 1 for every pair of points. So I'll put a few here and just draw the line that goes between them. So this is the graph of f of x. And if I compare this to g of x, okay, this one starts at 4, and its slope is a negative, so it's going down. It's going down 1 and over 2. So it looks like this. And I can actually already see where the two graphs meet. But after I get a few points here, I draw the line going between them. And I think that'll be good enough, and this is g of x. So we've actually answered this question by graphing both equations. I can see that the 2 points intersect, and I'll mark it in red. Right here, it looks like it has an x coordinate of 4 and a y coordinate of 2, so the actual point is 4, 2. Another way that you can figure out where two graphs meet is by setting them equal to each other. F of x is equal to g of x. So what I'll do is write the equations for both of these functions below. So let's see, f of x is equal to x minus 2, and g of x is equal to negative 1/2 x plus 4. So here's a way where you don't have to use a graph to get the same answer. You can just go to the equations and work with them. If I solve this, it'll give me an x value, and I know the answer should be 4. But let's see, to solve this equation, this linear equation for x, I think I'm going to multiply both sides by 2. It'll cancel the fraction, but double every value. So let's see, we get 2x minus 4 is equal to negative x plus 8. I just multiplied both sides by 2. Okay, I think next I'm going to add x to both sides. So now I have 3x minus 4 is equal to just 8. I'll now add 4 to both sides, and I get that 3x is equal to 12. Okay, now my first step, I multiplied both sides by 2, and that gave me a new equation. Here, I'm going to divide both sides by the same number. I'm going to divide by 3. And that gives me x is equal to 4, which is great. I knew that's what the answer had to be, but if you don't want to use a graph, like here's an analytic way of getting your answer. So this is the approach we'll take with the remainder of this lesson. We'll solve a linear equation just by manipulating both sides of the equal sign. Okay, so for example 2, again, I just want to solve a linear equation, but I don't want to use a graph. I just want to somehow simplify the left and the right side and combine like terms. Our general strategy will be, after we multiply both sides out, put all the x's on one side, everything that doesn't have an x on the other, and that should give you your answer. So to start with, let's see. On the left side, I see some parentheses, so I know I can multiply this 0.1 into there, and I can do the same thing on the right side, distribute 3 to both terms. So the left side becomes 2x minus 0.5, and then I have minus x plus 4, and that's going to be equal to 3x plus 21. Okay, so I've multiplied both sides out. I think next I'm going to combine some like terms just to make both sides look a little bit easier to work with. So on the left side, I have a 2x and I'm subtracting x, so I know that's going to be just x. I also have negative 0.5 and a plus 4, so I know that's going to be a positive 3.5. So the left side simplified nicely. And the right side, well, there's no like terms. I'm just going to copy down 3x plus 21. All right, so I think next what I'm going to do is, I think I'll subtract x from both sides. And so this becomes 3.5 is equal to 2x plus 21. And so since all of the x's are on the right, I think I'll subtract 21 from both sides. And so I get 2x on one side. And on the left side, I have negative 17.5. Okay. So the last step is to get x by itself. I have a 2x on the right. I know if I divide both sides by 2, on the right, I have just x. And if I take half of 17.5, I get 8.75, and that's going to be negative. And this is it. This is the answer to the original equation. So here, this is just a lot faster than trying to graph the left side, graph the right side to see where they intersect. We can just like go right analytically through this equation. And for the last example, same idea. I just would like to solve this linear equation. This one has, let's see, it has fractions in it. I think a good approach here would be to try to cancel the fractions from the equation. And we'll do that by multiplying both sides by the least common denominator of the three numbers that appear. So we have, what's the least common denominator of 2, 5, and 10? So that would be 10. 10 works for both. 2 and 5 can both multiply to 10. So I think my first step here is going to be, okay, I'm going to multiply both sides by the same amount. That means I'll have a new equation that will have no fractions in it. So on the left, I'll multiply the whole thing by 10. So we have x plus 4 over 2 minus 2x minus 3 over 5, and that whole thing multiplied by 10. And on the other side, multiplying that by 10 as well, and I'll copy down 1 minus x over 10. So the right side simplifies pretty nicely. So it's really 10 over 1. I know I can just go ahead and cancel those 10s because one is in the denominator and one is in the numerator. So the right side simplifies pretty well. It's just going to be 1 minus x. But the right side, maybe just want to be a little bit more careful with. This 10 is being distributed to both of those terms. So I'm going to write that out a little bit more carefully. That is, I'll write 10 over 1 times x plus 4 over 2 minus another 10 over 1 times 2x minus 3 over 5. So when I want to simplify this, let's see, this 2 goes into itself once and it goes into 10 5 times. This 5 goes into itself once, but it goes into 10 2 times. Copying this new equation down, we have 5, but it's multiplied by x plus 4, the whole thing, which is why I'm putting parentheses. Then I have minus the 2, and again, that's multiplied by 2x minus 3 with parentheses. And this is still equal to 1 minus x. So if you're dealing with fractions, this is a pretty good strategy to remove them from the equation. Now I can just do what we were doing in the previous example, where I'll distribute the 5, the negative 2, and combine some like terms. So we have, let's see, 5x plus 20 minus 4x plus 6, and this is equal to 1 minus x. Okay, I think I'll simplify the left side. I have a 5x and a subtracting 4x, so that's just x. And there's 20 plus 6, so that's just plus 26, is equal to 1 minus x. And I think what I'll do is add x to both sides. And in the same step, you can do this all at once. Eventually, I know I'm going to subtract 26 from both sides, so why not just do that right in the same line? We have 2x, the 26's cancel. Then we have 1 minus 26, which is negative 25, and the other x's cancel as well. If I now divide both sides by 2, I have my solution. X is equal to negative 12.5. We could take this value, go back up to the very first equation, plug this in place of all the x's just to make sure the left side is equal to the right. But I think we're going to leave this problem here and say that I know my solution, and that is it.